Hello, welcome physics students. I want to walk you through the pivot for Unit 6 that analyzes collisions. And I want to go through some of the details to help you kind of decipher, especially the second part. So basically what this does is it has some video simulations that have different collisions occurring between these different types of carts on a friction-free track. So they're on an air track, and when they collide together, they're transferring energy from one cart to the next. And we can change the type of collision. If you click on this, you can change what type of collision is happening. Either the left is stationary, or maybe the right is faster. The difference, or they may be same masses, to kind of see different results in terms of what happens with the energy. And so that's what they're asking you to do in these first ones. Pick a collision that you're going to use. What are you going to use? Find the energy before and after. So one thing that you're going to need for kinetic energy is velocity. And that's where you're going to use your ruler and your stopwatch tool. And so what I recommend is after you have one of the things loaded up, kind of see what happens, play it back and forth a little bit, and then get your rulers lined up so that you know when you're measuring the distance and time, it's happening when it's moving at a constant velocity. So I might start here, and maybe this would be my my 0 mark, so I can see this part of the glider is going to be lined up with 0. And then I'm just going to play it forward until it's right before it hits. I don't want it to bump, because then that's actually slowing down. There's an acceleration then at the end. So I want it to be maintaining a constant velocity. I'm going to assume that that's true. So I can start my watch at 0 here and just go forward until maybe about there. All right, so now that's 20 centimeters in 0.3917 seconds. Distance, 20, divided by time, 0.3917. That's my velocity that I can use in my kinetic energy equation. Okay, so we're going to use the same idea for part 2 as well. So I'm going to scroll down to here, and this one is going to ask us to do several experiments, and they're asking us to find quantities that we can both measure directly and some that we can calculate. And I'm just going to give you a big hint. Think of momentum. Calculate that mass times the velocity. And that's going to be the thing that you're going to want to focus on. So they're telling you in the data table, and notice if you collapse this, you're actually going to be testing 4 different things. Okay, so I'm just going to expand this again. And in the first one, we want to have it be the masses are equal and it's elastic. So I've set that up already. Hit the button here to change it, but I already have it set up, elastic and equal. And then similarly, I need to find the velocity that it comes in at and the velocity that this one leaves at after the collision. And I'm just going to record that in my data table here. They're already telling me the masses, which is super helpful. I'm going to record those velocities. So I can then set this up to where I think it's moving at a constant speed, maybe in this range here. So I'm going to move my, I'm going to set my timer right here. I'm going to set this at 0, and I'm going to move it until maybe it's at 20. So now I'm going to take 20 divided by 0.4, that's 50. So that is the velocity that I can record right here. Okay. Now the right glider wasn't moving before the collision, so its velocity is 0. Then after the collision, I'm going to do the same thing. I'm going to let them collide together. Oh, then the first glider comes to a stop, and the next one maintains a constant velocity. Now I got to be really picky here. I'm not going to measure it right after the collision, because I want it to maintain a constant velocity. So I'm going to let it go towards the end of the clip, and maybe I'll start right about here. Okay, so that maybe this is my 0 spot. There we go. And I'm going to go maybe those 20 centimeters, and it looks like it's right at, let's go just a bit more. It's right at about 0.42. Okay, so once again, 20 divided by 0.42. Let me get that for you quick. All right. That one's going to be about 47, 48. All right, so the left glider was 0. Again, same mass, 0.15, and this is about 48 centimeters per second. It's going to calculate then a little bit of a percent change, okay? I can also then calculate the momentum. All right, so I'm going to take this mass times velocity, my 0.15 times 50, and that's 7.5. It's okay if it's not in kilograms and well, this or meters per second. I think we'll be okay if we keep it in centimeters per second, as long as we're consistent. This one is 0. There's my change, and now I'm going to have 0 and 48 times 0.15. All right, and that is, hang on a second. There you go, 7.2. Now, ideally, these are going to be really close to each other. Again, a little bit of a percent change there. You're going to want to do the same thing by changing where it's elastic collision, but the masses are now unequal. You want to do the same thing, find the velocity, find the momentum, and then figure out how different they are when you're comparing all those. All right, so that's basically the idea. Please reach out if you have any questions. The key to this is making sure that each of these carts is maintaining a constant velocity when you start measuring the distance in time. Use your tools and use the video to reset and change each of the instances at the bottom as needed. All right, please reach out if you have any questions. Thanks, and have a great day.